Good morning, students. So in earlier class, we seen that how the rolling contact bearings selection. So when it is subjected to the variable type of loads. So this is also the continuation class for that. So we can also see along with the rolling contact bearings variable load selection. We can also see that how the reliability of the bearing that is life other than the 90% if they can give. So how the bearing life can be calculated at the 90% reliability. In today's class, we can see one more example problem for the bearings that is subjected to the variable loads. So let us see how the bearings are going to be selected when it is subjected to the variable loads. So let us go into the problem. So here, so this is the thing what you have derived in the earlier class. So we've taken the three different loads with the three different time duration of periods. So like with the successive speeds of N1, N2, N3 with the load magnitudes of P1, P2 as well as P3. So that is what we have derived in the earlier class. So that is the life in the generalizedly we know that the life of the bearing can be calculated by L is given by C by P whole power K. From that we written that the life consumed, the fraction of life consumed for one revolution can be written as 1 by L1. That is can be from that we can written as P1 by C whole power K into 1 by 10 power 6. So that is what we have written. So for the different time duration as we taken for one complete that is one complete work cycle, we can divide it into three number of time duration cycles. So that is with the successive speeds of N1, N2 and N3. For that case, so that the life consumed for the N1 number of revolutions that can be written as a P1 by C whole power K into N1 by 10 power 6 that we have seen in earlier class. Similar to that, for the life consumed for the N2 number of revolutions can be given by P2 by C whole power K into N2 by 10 power 6. Similarly, for the life consumed for N3 number of revolutions can be given by P1 by C whole power K into N3 by 10 power 6. So that we written that the life consumed for different time durations, but for calculating the total life consumed for one complete life cycle can be given by the sum of the lives that will be the fraction of life consumed during all the time durations. So that the sum of all the fraction of lives consumed can be given by the total amount of life consumed by the bearing for one complete work cycle. That is a sum of so that can be written as a sum of all the lives consumed. So this is the life consumed for N1 revolutions. Similarly N2. So similarly N3 number of revolutions up to that extent. So that is X number of that is up to the X time period we can consider. So up to that extent, this is the fraction of life that consumed. The sum of all the fraction of life that use the total life of the bearing consumed for one complete work cycle. That we are seeing, we are aware of that. So we can come into the continuation of that. So you know that the total life consumed can also be written as N equal to L equal to N into P power K by 10 power 6 into C power K. So by equating earlier equation with this equation, so the 10 power 6 and C power K get cancelled. From that we written that P power PE, that is the equivalent dynamic load for variable loads, that is written as N1 P1 power K plus N2 P2 power K up to the extent of Nx Px power K by total number of revolutions that is given by, so that is N is given by N1 plus N2 plus N3 up to Nx. So from that we derived an equation. So in the previous class, that is the final equation for the equivalent dynamic load can be given by PE equal to sum of N into P power K whole divided by sum of the number of revolutions, that is the sum of N can written as whole power 1 by K. So we know that so from these cases, so the P1, P2 as well as up to Px, we, as I stated that it is the equivalent load rating or the dynamic load rating. So that is capital P1, P2 and P3 are up to Px. So we need to calculate using the relation XVFR plus YFA into S. So for that particular duration of time period, we need to take that particular load of FR1, FR2, FR3 and FA1, FR2, FA2 and FA3 likewise. So we need to calculate individually the life. So in this class you can see how the selection of the bearing can be going to take based upon this expression, that is the bearing subjected to the variable loads. Clear? So let us go into the example problem of that. It is an example problem for the bearing subjected to the variable load. So you can see it is the type of the bearing is clearly mentioned here. It is a single row deep groove ball bearing. So it is subjected to some work cycle, and this work cycle can be divided into 4 parts. So this is the part 1, 2, 3 and 4. 4 parts are there in the one complete work cycle, and it is operating with a life of 15,000 hours. So that is directly it is given LH. So life in hours of service, LH is given, and the total operating work cycle is stated in the type. So with the type of load is mentioned. So this is the with the fraction of life, fraction of cycle. So for the 1/10th cycle of the frac, that is the total complete work cycle. So it is subjected to the heavy shock, that is a type of load, and the magnitudes of the loads are specified. That is a radial load and the axial load. So here radial load can be specified by FR and the axial load can be specified by FA. So but here it is a first component of cycle in our complete work cycle. So we can represent these 2000 newtons as FR1 and these 1200 newtons as FA1. So and the speed, that particular speed, specified speed is given. So we need to calculate the number of revolutions that the FR1 and FA1 is going to act upon the during these period of cycle. That is 1/10 into. So you can multiply the speed. It can use the total number of revolutions that the bearing can subjected to these heavy shock type of load with respect to the FA1 and FR1. And as well as it can also directly given the service factor. So as in earlier cases, we have taken the service factor from data book based upon the type of load. But here they clearly mention the type, that is a service factor is directly given in the problem. Clear? So likewise they can mention, so for the second period of time it can also 1/10 period, and the third time duration is 1/5, and the fourth one is 3/5 the times of the total life cycle, that is work cycle. So from that the type of loads are given: moderate shock, light shock and no shock load, and all the magnitudes in the radial load condition and the axial load condition is also given, and the speeds, specific speeds at that particular duration of time is also given, and each and every service factor is also given. That is S1, S2, S3 and S4 is clearly specified in the given data. Clear? Apart of that, they can also given. So if you want to calculate the P1, so we require X1 and Y1. So for that we require FA by FR and FA by C0 ratio. So again C0 is unknown, we need to assume. So it will be a little bit difficult to assume all FA by C0 for all the cycles to calculate, in order to calculate dynamic load, equivalent dynamic load for the first period of cycle, second period of cycle, third period and fourth period. So instead they can clearly mention for all the period of cycles, the load factors in axial loading as well as radial loading is clearly taken as they specified, assuming it as an X and Y as a constant. So and it is taken as 1 and 1.5 respectively for all the duration of cycles. Clear? And as well as they can also specify the one more assumption, it is the inner race rotates here. So there is they clearly mentioned that it is inner race rotate, so that V factor, that is V is given, so that we can take V as 1. So if it is an outer race rotate, is it 1.2? So it is clearly mentioned it is a inner race rotates, so that you can take V is 1. So X and Y is also given, as well as the service factors is also given, that is S1, S2, S3 and as well as S4 up to for all the cycles they given the S factor. So FA1 and FR1, FA2 and FR2 likewise we know the magnitude, so that you can calculate so P1, that is a P1 and the equivalent dynamic load for all the cycles P1, P2, P3 as well as P4 using the XVFR plus YFA equation. So let us see so how to calculate, select the bearing. So here coming to the data, so it is as given in the given data. So FR1 as well as FA1 is given, so as well as S1, it is mentioned with S1. So similarly FR2 and FA2 and S2 and FA3, that is a radial load in the third cycle, so and the axial load in the third cycle, and the service factor is given, and here the FR4 is given, that is a fourth cycle radial load and the fourth cycle axial load FA4 and S4 service factor for fourth cycle. So that is fourth period of cycle. Similarly, we need to calculate N1. So as I stated, they given the specified speed, we need to mention the number of revolutions so that the FA1 and FR1 is subjecting to during that particular period of time. So we need to calculate the number of revolutions of the bearing can be given by 1/10. They specified it is a fraction of cycle, that is a 1/10 with the speed of 400 rpm. So it is given as 40 rpm. Similarly, you can also calculate N2, N3 and N4. So that I can calculate the total number of revolutions that the bearing operate can be given by N1 plus N2 plus N3 plus N4. That we know that, so that we may get the total N. So and the life of bearing is given in terms of hours of service. LH is given, and X and Y is given in data. So it is assumed as a constant for all the fractional cycles. X and Y is say so 1 and 1.5, and also it stated it is an inner race rotates. So we are taking so inner race rotates V equal to 1. Clear? So this is the given data. So first of all, we can calculate the life of bearing in terms of million revolutions. So they specified in terms of hours of service LH. So we can calculate the life in million revolutions by using the relation 60 N LH by 10 power 6. So that LH is given life in hours of service, and N that is given by N1 plus N2 plus N3 plus N4. So you can sum up all the number of revolutions. You can calculate the total number of revolutions of the bearing. So you can calculate life in million revolutions. So after that, using the X and Y values, you can calculate so P1. So using these FR1 and FA1 and S1, and X and Y is known. So you can calculate the P1 as well as the P2. So similarly P3, equivalent dynamic load for that particular period of time, as well as P4. So using that P1, P2, P3 and P4 and N1, N2, N3 and N4, you can calculate the equivalent dynamic load in variable loadings, that is PE, that is given by P1 and P1 power K into N1 plus P2 power K into N2 plus P3 power K plus N3. So likewise divided by total number of revolutions here. So let us see, so what is life in million revolutions? So here, so first of all, I calculated the equivalent dynamic load for that particular period of time. So that is P1, P2, P3 and P4 using the relations XVFR plus YFA into S. So you know that all the data is given. You can simply substitute in the equation. So I get the values here clearly. So that so as I stated that you need to calculate the equivalent dynamic load in a variable loading. You need to calculate, that is the PE. So we can calculate PE using this relation. So that is N1 P1 power K plus N2 P2 power K plus N3 P3 power K plus N4 P4 power K by total number of revolutions N, that is given by N1 plus N2 plus N3 plus N4. So 4 power 1 by K. So we can substitute all the values. So N1 is known 40 and P1 is calculated here, and N2 is known 50 and P2 is calculated here 4500 newtons. Similarly N3 is known and is known. So P3 is calculated as well as, so we can multiply here. So N4 P4 power K. So divided by N4 we need to write. So whole power 1 by K. So K is constant for ball bearing. It is taken as 3. So you can substitute all the values. So in this equation you can get the equivalent dynamic load for the bearing in a variable loading condition. It is given by 5767 newtons. Clear? So after that I can calculate the life of the bearing in million revolutions by using the relation 60 N LH by 10 power. Here I can see it is a life of bearing. So simply substitute N is given by total number of revolutions N1 plus N2 plus N3 N4. We can substitute, it is given as 690. So and the life in hours is given 15,000 kilonewtons. Sorry, 15,000 hours of service LH. So we may get 621 million revolutions. So using that I can calculate the dynamic load rating of the bearing, that is C is using the load life relation. So C is given by E into L power 1 by K. So from load life relation, that is L equal to C by P whole power K. From that you can written as a C value. So P is calculated, that is here you need to take the variable load, equivalent dynamic load in the variable loading can be substituted here 5727 newtons and 621 million revolutions are there. So 3 is a constant for K. So we can calculate 49 kilonewtons, that is a dynamic load carrying capacity of the bearing is getting. So based upon this dynamic load carrying capacity of the bearing, we need to select the bearing from the tables, that is a design data which starts from the light series bearing to the heavy series, that is a very light series that starts with, it is a deep groove ball bearing. So that very light series is 60 and the light series is 62 and the medium series is 63 and the heavy series is 64. So can start with a very light series, that is 60, and you can by using the trial and error method you can select the bearing based upon the given, that is a calculated dynamic load rating. So let us see which type of which designation of the bearing is suitable for this load carrying capacity. So based upon the dynamic load rating we need to select the bearing. So as I stated in the that is what the trial and error method. I done by using the trial and error method. The suitable type of bearing which is for this given application is that is a 6215. So here I started with the light series 6015 that may have the less dynamic load rating compared to the calculated value. So I go with a light series, that is a 62 series. So in there I can observe that for the 62 series I may have the capacity of 50 kilonewtons for that. So I selected with a diameter of 45 mm, sorry, 75 mm. So 6215. So this is having the 50 kilonewtons of dynamic capacity, so that our calculated value is only 49.19 kilonewtons. So that the selected type of bearing 6215 is very much suitable for our application. So likewise, we need to select the suitable type of bearing from the light series to the, that is very light series to the heavy series based upon the dynamic load rating. Clear? So this is how the bearings are to be selected. So you need to remember that here we have only 3 steps. So initially you need to calculate P. So either it is in steady load or the variable load. If it is a steady load, we have only a single load condition, one cycle. But in the variable load, we have the number of time cycles, so that you need to calculate the equivalent dynamic load in variable load. So either P or PE. So and the second step, we need to calculate life in million revolutions here. And finally, you can calculate the dynamic load carrying capacity C from the load life relation. These are the 3 main steps. So after that, you can calculate select the type of bearing from the design data book based upon the dynamic load rating capacity of the bearing from the design data book from the very light series to the heavy series based upon the given diameter also. If this diameter is not given, you can select the randomly for the optimum diameter in order to best suitable to withstand the calculated dynamic load rating. Clear? So this is how the bearings rolling contact bearings are going to be selected based upon the dynamic load rating. So this is an example problem. So as I stated that in the variable loading, instead of the number of revolutions that the bearing is subjected to, you can also take the time duration. So please note down these problems. So you can make this as an exercise problem. In these they mention the time duration of the cycles, that is at T1, T2 as well as at T3 or here they can also specify the speeds. So you need to calculate the N1, N2, N3 using these 25% of time, which means 24% means 1/4 of the total cycle. So one work cycle they can be divided into 3 parts. So here it is a 55%, 20% of the time, and it is only 55% of the time. So that you need to calculate N1, N2, N3, and in similar fashion you can select the bearing. LH is given. Expected life, average life, or in the as well as inner race limited, they mentioned that. And for the steady loads, the bearing is expected, the type of load condition is given, so that you can take service factor as 1. So you can calculate, so it is a pure radial load, so that you can take P1 as simply FR1, so P2 as FR2, and P3 as FR3. You can calculate the equivalent dynamic load PE in variable loading condition, and take calculate L million revolutions. So and calculate C dynamic load rating and select the suitable type of bearing. Clear? This is how the bearings are going to be selected, and so that I can finish the selection of bearing, that is a rolling contact bearings. So by this topic we finished the unit number 1. So far we have discussed. So what is the need of the main need of bearing. So, why the bearings are very much essential in any of the machine component that we see in that. So it is going to support, as well as it will allow the relative motion, as well as it will constrain the motion with respect to the another. So as well as it will, we need to provide a better lubrication to reduce the friction, as well as the wear, and again as the corrosion that we all see, and as well as you can see the broad classification of bearings. So based upon the type of load conditions it can support, and the nature of contact between the two surfaces, which is radial bearings, axial bearings, that is thrust bearings. If it is in nature of contact, it may be in sliding contact bearings and rolling contact bearings. So as per our syllabus, we may have both the sliding contact bearing design as well as the rolling contact bearing design, and we can see the sliding contact bearing classification. So we've seen that the broad classification of sliding contact bearings based upon the type of loads. So again, you can see, so what are the classification based upon the modes of lubrication like hydrodynamic and hydrostatic type. So that is a thick film lubrication. In the modes of lubrication, thick film, thin film and zero film. In thick film, so it can be obtained by means of either hydrodynamic and hydrostatic. But as per our syllabus, we have an hydrodynamic, so which have to so we need to keen observation on the hydrodynamic. Why? Because as per our syllabus, we have been major contribution in the syllabus is hydrodynamic type of bearings. So we see in the various terms used in hydrodynamic bearings and how the thick film is going to be formed in the hydrodynamic. That is science of lubrication, as well as how the thick film going to be formed by means of viscous friction, by means of wet film, as well as the squeeze film lubrication that we have studied. And as well as the various terms used in the hydrodynamic bearings you can see in, and you can also see the design procedure of hydrodynamic bearing. Design procedure, how the hydrodynamic bearings are going to be designed based upon the two methods. Again, we have seen by means of Mecker's test results. So that is the coefficient of friction can be the users of coefficient of friction equation designed by means of given by means of Mecker's brothers. That is mu equal to 33 by 10 power 8 into Zn by P d by C plus K. Using that method, we can calculate the design procedure for journal bearing, as well as we can also see the design procedure based upon the Boyd charts. So that is a Raymond and the Boyd charts. That is using the non-dimensionless performance parameters like flow ratio and the coefficient of friction variable, flow variable, as well as the Sommerfeld number and the different LBD ratios. Using that, we can see the design procedure for the hydrodynamic bearings. So up to that extent, the hydrodynamic, that is sliding contact bearings, we are seen. After that, we entered into, we are also seen so the classification of rolling contact bearings. So that is based upon the type of rolling contacts between the two surfaces. We have the ball bearings and roller bearings, and we can also see now what are the different types of ball bearings we have, different types of roller bearings we may have. So based upon the different applications, which type of bearing we are going to select, that is also we are observed very neatly. So and after that you can see so how the life of the bearing can be calculated. Life of the bearing, and finally you can we have discussed how the bearing is going to be selected. So in under variable loading condition like steady loads as well as the variable loads. Apart of that, we can also see what is the reliability of the bearing, how the bearings are going to be, the life of the bearing is going to be calculated when it is given rather than the 90% of the life, so that I can select the type of bearing based upon the dynamic load rating. So from the design data book, which from starts with the very light series to the heavy series. So these will these many of the topics we discussed in unit number 1 that will fulfill whatever the objectives we are stated in the beginning of the unit 1. That is as I think that so that is the life of the bearing and the selection of the ball bearing, the design of sliding contact bearing. These are all the main objectives of the unit 1. So that these many points of the syllabus that will the structure that we discussed that will fulfills our main objective of the unit 1. And in the coming classes, we can go with the unit number 2, which is the main designs that considers with the main components of IC engine. So the only the main components we consider like cylinder, piston, crankshaft, and connecting. These four type of that is the components, the main components in the IC engine. These are the four components as per our syllabus. We can also have these four IC engine component designs are there that we will discuss in unit number 2. We may have only 4 designs in unit number 2. So in unit number 1, we have only 2 designs, that is a sliding contact bearings as well as selection of ball bearings. Clear? In sliding contact bearings, we have Mecker's brothers and Boyd charts, and in rolling contact bearing selection is only one type. So it will be very much important in this chapter, that is the design of sliding contact and selection of rolling contact bearings. We will discuss and continue with the very new topics in the next class with the unit number 2, that is design of IC engine components. Thank you.